Well, as it says, introductory comments, there are as many ways to think and design something as there are people. Terminology is often regional. Terms can mean different things. Everyone thinks their way is the right way. Welcome to the consolidation of framing concepts I've lived with over a couple of decades. I hope this helps, and also to stir some thinking and conversation. Let's begin. All right, so the rest of this you can read. But pretty much my point is nobody just has a hammer or just has a screwdriver or just has a wrench. We have the right tool for the job. And the same is true for software. If you think you can go through your design life and only use one type of software, you have to ask yourself why. Chief Architect is really good, and I've enjoyed it. But there's this term called workaround. And that means it doesn't obviously do what it should do. And so people figure out ways to make it do what you want. And in some instances, that's a lot of work. So I get it. Some people don't want to have multiple software platforms because it could be expensive or you have to learn something new. But I do plans for permit. Chief does most everything pretty good, but their framing and their 3D rendering of framing is broken. And so I'm going to point some of those things out today and tell you that I have used SketchUp. I've been talked into SketchUp by Mr. Larry Belk. And here's an example. I used the Medic BIM foundation tool created by Mr. Nathaniel Wilkerson to do the foundation. And as you can see, this is just a screenshot of a SketchUp model. But look at the detail that he puts into SketchUp. He has a wall tool, a roof tool, and some other things. But the foundation is all done with his extension, and it's really fast. This whole thing was less than 60 seconds to, point out the parameters, and then it just does what it does. I hand built this roof in SketchUp, so it's a little slower. But this all got started because the way Chief measures its rafters doesn't help me set up a cut sheet. So they have made some changes. Now when you double click a rafter, it goes from the long point at the top down to the short point inside the subfascia. So that's pretty cool. That's different than what it was just last year. But then when you turn on the overhang area, or if you dimension from framing out to the outside of subfascia, if you call this a 16-inch overhang and you dimension from framing to over this number 10, it's 15 inches. And so that means that my fascia board out here must be 1 inch, because in their software world, they go face of framing to over fascia is the overhang. And that's not true. It's not correct. So I did a bunch of research. I was looking around, and there is no standard from the people that I was able to find and read online. Mostly, the overhang is kind of determined by what material do they provide on the job site. Like if the builder has pre-perforated Hardy 12-inch or some other brand 16-inch or whatever, then your overhang is going to be from the face of whatever's here. This might be half-inch. It might be insulation and then OSB. Those like the R6 or R4 board or whatever. And it's going to come out the distance of the soffit. And that's where your subfascia is going to stop so that you can attach your soffit to the subfascia here and here. And then your fascia board goes on the outside of that. So regardless of what the plan says and regardless how Chief Architect would dimension, your overhang is not going to be to the outside of fascia because There's no way I'm ripping down pre-primed concrete soffit to make it fit something that a piece of paper, like a set of plans, says, oh, it's got to be to the outside of this. No. This piece of soffit dictates that. And the only time you really get into trouble with overhangs is if your overhang is going into like a setback area or some kind of area where it specifically says from the permit office that you cannot extend into that area. And then you'll figure out how to make that work. Otherwise, you go with whatever's delivered on site to use as soffit. And the other question I had was when people get adamant about, oh no, the overhang is always to the outside of fascia. Okay, what if somebody puts gutters on there? Now the gutter sticks out even farther. Do you go to the outside of gutters? I mean, I understand the point where if you're looking straight down from space, whatever's sticking out from your house the farthest would be considered the overhang. But that's not how it's framed. How it's framed is whatever the material is for the soffit, you make your subframing all match up to that. I mean, up here, it's crazy. They don't even use an outside sub fascia. They use exposed tails. They don't use any of this. They don't want to spend the money because up here, I don't know. They like going cheap, I guess. I don't know. Builders are what they want to be. So you get, you rip a 2x4 tail, or mostly it's trusses. They come with the 2x4 sticking out here, wild out 24 inches. And you cut it back to whatever your exposed overhang is going to be. And you take your fascia board and you nail it straight onto the tail, which I've never liked that because now you're just a couple nails or a couple screws, whatever, into the end of each tail. And that's not going to hold up very, it's just not. So I've come up with this PDF that you see here before you, and I'm going to include a link. Once it's complete, I'll include a link in the video as kind of a, like, you don't have to do it my way, but we can start using terminology that maybe sounds similar. Or I would love to hear in the comments people share how they do things. This just happens to be a closed soffit with middle continuous venting, but you could cut in those 8x16 screened vents. You could use a solid piece that's all perforated. There's so many different ways to do this. I threw this in here because there was a big blank space here, and I thought it was kind of cool because when I started framing in Germantown outside of Memphis and a little bit up in Clarksville in Tennessee, this is how they did things. They would joist, put a rim board. Sometimes they would subfloor like 24 inches in or 48 inches in, and then run a 2x6 plate down. And that was awesome for insulation, which they really didn't need. But it also, it made like if you had attic space, you gained all this right here. So I thought that was an interesting way to do business. Here's the nailing schedule. So this is good to have so you know how things get connected. Here's the components of a rafter. So you can, see, this is Chief. I like Chief for what it's really good at. And notes, dimensioning, text, it's awesome. I drew this in Chief, actually. This speed square. I think I'd like to draw it in SketchUp, and then I can have it in 3D and spin it around. But so this is an interesting little model that you can use to when you're discussing parts of the house with people. Top plate, double plate. Some people call it top plate, very top plate. There's all kinds of different ways people talk about that. And then joists. And the span of a joist is inside to inside of the wall. And the span of the roof is from over the outside to over the outside. So the word span even has multiple meanings. In this instance, I'm showing hips that have a double bevel on top. And this is the backing bevel. For this 8 and 12, since it's common all the way around, that works out to be 23.09 degrees. You set on your saw, and you drive down one way, and you flip the board over, and you drive back down the other way, and you end up with this peak. And what that does, your height above plate for your rafters, whatever that turns out to be once we start talking about it later on, your hip's going to be the same. You won't have to drop your hip. Because if you don't do this rip, then the edges of your hip stick high. If you go that excuse me, it's kind of late. Oh. And this way is better. It doesn't take much extra time either if you just do it. When you get to the ends, you double a joist, and then you turn direction. You put 2x6, 2x8, whatever out. So you create a completely sheetrockable ceiling. And like I said, once I have all these pages done, I will include the link so you can come back to this video and then download this PDF and keep it. It might be something interesting that you can study if you want to be that kind of framer. So yesterday, after framing for 25 years and not even really thinking about it, I was working on this drawing right here, and it made me think of something. Look at this. This is wall sheathing, and I've got it stopped at the top plate. I didn't carry it up to the top of the double plate. And in my entire framing career, when I started, we would put the rafters on framing with no sheathing because we were building on slabs, and we would level everything and brace it out. And then we would sheet it after the fact, and we would just tuck the sheeting up as high as we could get it. It would hit the rafter tail, and then we would nail it on. And I was looking at this going, because like Washington State with all the trusses, the truss stops here and goes up like a 1/4 inch, and then the 2x4 comes down. So plywood can work all the way to the top. And so when we build walls up here, we have them squared on the floor, because we're on crawl spaces, so the floor is pretty level. And then we sheet them while they're laying down, and then we stand them up. And we've always squared the walls, and then you pull the sheeting all the way up to the top of the double plate, and you nail it all on. Well, I started thinking about this just yesterday, and the double plate doesn't do anything for a shear wall. It does not add any strength to shear. I looked in the code book. I looked all over. The double plate's sole purpose in life is to tie corners together and T-walls together. Wherever walls intersect, if this wall and this wall come together and they're being nailed together, the double plate is attached and extends over and ties these two together. And that's it. That's the purpose of the double plate. Some people say, well, it makes it stronger in between. This is a 14.5 inch span. And if you're going to put something right there in the middle, first of all, you need a stack frame, which means joists and rafters. You pick one. I usually like my rafters to go right above on where the studs are, and the joists can go on either side, as long as they're on the same side equally through. But this is nuts. I realize, because some of the guys, like, who are they? Awesome Framers. In some instances, they get rid of this second double plate, and they'll just use metal strapping. It's authorized by the code or engineering, either one, to connect this wall to this wall. It's totally acceptable. I'm not a big fan of losing that double plate, because if it's a wall that's 8 feet high, now you're not going to get your sheetrock in there without having to cut your sheetrock to fit. So I am never going to give up the double plate, but I'm thinking I'm going to build all my outside plywooded walls, single plate on the bottom, stud, single plate on the top, square them, sheet them, stand them, and then use a nice straight 16-foot 2x to double plate everything. And I've seen that done before on the inside, where guys will just raise the single top plate, get the walls up, and then they'll come through and lace it all together. But it was just weird when that hit me. I was like, yes. So call me stupid or like the idea. I bet you some of these guys are already doing this. This is just how you've always done it. And I never had seen that, so I didn't know it was a thing. But that's how I want to do it. And the reason is because I want this rafter tight to framing. Everything that you do as a framer is measured from framing some way. Either roofs, overframing, or if you're pulling measurements throughout the house, it's you hook and you go over to it, or whatever. However, a good designer fixes that and gives you dimensions that way. But so that was that. And then the other thing was chief architect and their overhang thing. And we've already kind of discussed that. The real overhang is subfascia to whatever's on the outside of the wall so that you can make fit whatever's on the site for the soffit. And then this fascia can change. This could be 3/4 inch, 1 inch, 2 inch. This is a variable. This is just finished work, but the structure is always where the dimensions need to go. And that right there, nobody really gets that picky about it. I just thought back to all the times I've cut roof, and I never really thought about the overhang. I would look at the plans. I'd figure out what it needed to be. I would cut a tail pattern, and then I would set the tail pattern down, and then I would start measuring rafters, and then grab the tail pattern and trace out the tail, and give her, go to town. So I focus mostly on what's the span of the building, or how do I get the right rafter length so that the ridge is in the correct location, all that good stuff. Next page. So this is from the code book right here. This is R802.4.5. And I added things that I've either seen or I've incorporated into what I do. Like wind ties. That's a Germantown, Tennessee, what is that? The New Madrid fault line, seismic D2. You can do that, or you can use metal strapping. Up here in Washington, they do metal strapping, and it's a pain because when you get your plywood up here and you're trying to shoot it into the rafter, sometimes your nails bend and bounce off, and yeah, it's got to be a better way, right? This is what I was talking about. This happens to be wall joists, and then a subfloor, and then 2x6, and then blocking in between. And this is a MTS 12 Simpson. Something twisted strap, whatever the M stands for. Drag strut was a thing we did in Memphis and Germantown. Had to do a seismic. They wanted to tie this rafter to a joist all the way across, back up on another drag strut to the joist. So you were creating a truss, and then you were anchoring it to the actual joist. So it was kind of cool. Here's how I do a purlin. And the only trick about the purlin that's cool is once you figure out what, so let me back up. I would always try and straighten these. So I would start with a really good board, and I would lay it out on the layouts of the roof, and I'd go to the middle, find a layout, look where my pop line was, and then hold it up there and tack it, just shoot from the face and on a toenail into the rafter, and then come down a little ways, move this rafter till it's in layout and shoot it. So now I've got a board that's following a pop line, and it's just hanging there. Then I can take my speed square and put it on top and look down the square where the board is, right here in the face of the board, this front face, and then look down onto where there's a wall or something that is a legitimate load-bearing thing down here. And then that's where I would measure from there to the bottom of the purlin, and then up to the top of the rafter. And with those lengths, I could say, whatever this roof pitch is, that's what that angle is. And then they would cut down here 1.5 inches, and they'd rip it all the way through, and then they'd cut it off. So I would get these thrown up to me, this bottom pinkish one. And as you can see right here, you lift it up, the face of it right here is flush with the face of this. And so you can snug it on the wall or whatever and kick it with your foot and get it really, really tight. And then shoot through the purlin down into it and shoot it at the bottom, and then come up and pull the rafter over and like here, face nail this way and then a couple back the other way. So now this bottom purlin brace is pretty snug. And then you come back with another 2x4. It doesn't have to be beveled like this, but hey, it's software and so it's easy. It could just be square cut at the bottom. But then you measure up and you notch out another 1.5 inches, and then you go up, and the depth of the rafter is what this notch is. So 5.5, 2x6, 7.25, 2x8. And you nail your way up here. You nail through into the purlin, and then you face nail, back nail into the rafter. And this becomes right here is so awesome. I mean, it is not going anywhere. And you just do the same. The code says no more than 4 feet apart. And sometimes you don't have walls or anything sufficient that you can brace off of. So in those instances, you're allowed to go over to the angle of a 45. And you could tilt this pink one. You could nail it here and then angle it over and have it brace here. And then the other part of the code says you can't have more than 8 feet of the purlin just dangling out there like over here. So you can angle these to go from wall to wall and stuff like that. Here's the code for that. And then this one kind of blew me away. I've always just used 4 3/8 vertical right here for the height above plate, and then a 2x8 we use 6 3/8, and those aren't right. We've been building houses wrong, I guess, back in Houston. You're supposed to take the rafter, whatever type it is, 2x6, so this is 5.5, divided by 4 even spaces. Same here, 2x8 divided by 4 even spaces. 2x12, same thing. And the maximum that code says is one of these 4. So you can cut your seat cut. These are all 12 and 12 pitch. You can cut your seat cut and then your vertical. And if you go any more than that, so like if I was to make this like I used to, 4 3/8, I'm cutting beyond the D4 max. And yeah, I don't do that anymore. If the code is there, there's a reason. They've built these super testing facilities where they shake the crap out of buildings, and they've tested all kinds of stuff. So if that's the code, let's just do it. Here's a table. You can pause and screenshot this, or it'll be in the PDF. But this is for figuring out that notch based off the pitch. So if you were doing a 5 and 12 and you're using 2x6s, 4.5 would work. Oh, you know what? That makes sense, because if you're doing a lower pitch, let's see, where's 4 3/8? Right here. So 4 and 12 would be 4 3/8. So yeah, sometimes I guess we were right. But there's that. And you know, here, this is the disappointing part. I had an hour-long video with Mr. Larry Belk, and I recorded it from Zoom, but it's corrupted. So I'm trying to rebuild this tonight, and it won't be as much fun because Larry brings 50 years worth of experience, so he's pretty amazing. So now let's talk about Construction Master. So all these are from the desktop version of Construction Master, where you can take screenshots of that. And then I also use Build Calc on a phone, and this is the actual Construction Master that rides in my nail bags. So I'm not opposed to Construction Master. It's really good at what it does. However, when they did the math for figuring out jacks, they have no way of knowing how thick your hips or valleys are, or your ridge. There's no input for that. And so typically what happens is, here's your 20-foot span, and when you take off 3/4 from each side, you're left with 9'11¼ on this side and 9'11¼ on that side. And so everybody goes, okay, well, let's figure out our rafters, and then we'll go from there. Well, as soon as you decide to jump over and do jacks, you're still going by that theoretical length. And the thickness of a hip even if they're both, say these are both 2 by 10 and 2 by 10, the thickness perpendicular of half of it is 3/4, right? 3/4 plus 3/4, 1.5 inches. The thickness of the hip or valley is not measured across the board. It's measured in the direction that the rafters are going. So when you touch the outer edge of the rafter, or the hip rafter, it's more than 3/4 to get to the center horizontally. So from this angle, coming at it this way, the calculator is immediately wrong because it is using the center line for its calculations, but it's actually off a little bit. And if you've framed a lot where you've decked the roof of a bunch of buildings, as you're getting your plywood and you're putting it on and you're coming to a hip, you'll notice that these jacks here aren't running parallel to the 4-foot edge of the plywood. And that used to bug me because I used to think, what did I do wrong? Why are these getting off? And it would get worse and worse as we got farther down here. Not enough that it would fail the roof. You know, the plywood will still catch enough on the top, and then on the bottom, you'll be fine. But it's not straight. And I wanted to know, why is it not straight? It should be. Everything we're doing is math. And I drew this out in AutoCAD many years ago, like 1993. And I drew everything to be the right size, 1.5 inches wide. And I would get all these horizontal runs, right? Like this is a horizontal run that's based off of the outside of the wall, touching the ridge. In fact, let's just go there. So this is better. There's your outside wall, and you're bumping into the ridge. And that is your span minus this ridge thickness divided by 2. So that was 9'11 1/4. And what I would do is I would take that number and I would do the math. I would go 9'11 1/4. And then I would multiply it by the roof pitch, like 8 and 12. I'd multiply it by 8, divide it by 12. And now I've got the vertical component of this. And then I would take this run squared plus this rise squared, and then take the square root, and that would give me this length. And the Construction Master does that real easy because you take this run and you type it in, and you push run, and then you type in the pitch, the angle, and you like 8 pitch. Now it's done. Now any other button you push, like diagonal or rise, it's going to give you the correct answer. And so it will give you the correct answer for this rafter. But as you see right here, this 3/4 of an inch here is different than this length right here. This length's a little longer. So in this little takeoff thing, I show the math, how this works. This is 3/4 on a hip rafter going perpendicular to the face of the board. But what you need to figure out is this N horizontal, and then the angle component is the 8 and 12 that's carrying across here. And then you can figure out the actual diagonal of what it is from when it touches the board to where it hits that center. And that's the difference. When you subtract that number, you take this number here and subtract 3/4, you're going to get how much you got to cut off of each one of these to make them run true. Because right now, what you're cutting, let me see, where is it here? Here's what Construction Master and Build Calc say. 10'4" and a 1/16 is what they think it's supposed to be. But instead, it should be 10'4" and 5/8. So actually, you're adding. My bad. You'll have to forgive me. It's what is it? Almost midnight, and I have. You know what? You don't care. So, anyways, I proofed this by drawing everything exact, and then measuring the horizontal component on the computer. And once I have that true horizontal component, then I can just add the roof pitch, and that'll give me the diagonal. And so once that was established, I figured out why. I was like, okay, why is AutoCAD saying it's different than this? And it was driving me nuts because I thought, well, this is Construction Master. They can't be wrong. But then I talked to the guy that invented BuildCalc, and he said, yeah, that was one of the harder things, was creating a programmable calculator that doesn't have variables you can input, because, on big, long valleys and hips, people like to go with LVLs. So you just made this wider, and or they might go with a double ridge or whatever. And so when you get that face angle doesn't transition over to this hip exact. It's close. And for some people, close enough is good enough. But if you want to know exactly what it is, you need to dive into it a little bit and figure it out. So you could study RPN, reverse Polish notation, and come up with your own equations. And then once I started using these, and then look, everything's really close. Like the increment's the same, the hip is the same. It's just these jacks, because you're cutting it off of something that's thicker than normal, than what you would expect. And once I started using this, all my jacks ran true. So, and I'd been just not even thinking about it until about 1990 maybe. And that was right when I was going to A&M. So, wow, got AutoCAD, Release 11. So then the last thing I want to talk about is, don't just trust Construction Master for everything. I drew this also in SketchUp. In fact, these jacks right here, this is 20 feet wide by 30 feet long. These jacks, I don't remember what angle I was at, and I grabbed them all and I put them on this page right here. So these are actually spaced out like they were sitting on a wall. And as you can tell, so SketchUp's awesome, but it's not perfect either. Their dimensioning is terrible. I guess it must be tough to dimension in 3D. I don't know, but like the font choice and how small it is, and I can't do much with it. Whereas Chief is light years ahead on presentation. But when you look at these lengths, the Construction Master, it had 0, 8, 11. And these are the real numbers. And the other way I can prove it, not just using a calculator, but created a spreadsheet that you just enter the numbers in the green of what you're doing, and then it will kick out a bunch of information. And here we go again. 10, 4, 10, that's 10 foot 4 and 5/8. 8, 9, 6, that's 8, 9 and 3/8. So there's 8, 9, 6, which is 8, 9 and 3/8, 10, 4 and 5/8. And so this took a while, and these are all proofed by taking a model and drawing it exactly with the right size, the right thickness, doing the layouts exactly on 16-inch centers, so that when you dimension it, the dimensions are honest. Because I had one guy say, well, you're just putting numbers on there. And I said, no, actually, you draw lines and you draw shapes. And then when you use the dimension tool, it's going to tell you in 1-to-1 in the model how big that is. And if it's not right, you can, like in Chief, you can click on it and then click on the dimension, and you can retype the dimension. It'll move that part. So if you take the time to draw super accurate, then your dimensions are valuable. They'll help you. So this is a roof that I framed in Germantown. And I was able to measure the slab a day or two before I showed up. And I was working with a big production framer. He gave me some guys to come over here and knock this house out. And they started framing. I popped the lines out exactly where the plan goes. This isn't the whole plan. This is the one I drew. But I told them, I said, we just got to get to where these green plates are. And, you know, in the South on slabs, they shoot the plate down or they hit it with cut nails. And so you've got your bottom plate already where it's supposed to be. And we just made sure everything was in the right location. And then since it was right, I already had all this electronically, and so I just run the calculations. Some of these tough things, like I would measure from right there to the long point horizontally, and then enter that information as the run, and then put a 9 and 12 pitch on it, and then it'll give me the length. This is the diagonal. And all of these, this little line on the outside was to the outside of whatever the overhang was. And as you can tell by looking, I didn't really care. I just knew that wherever it is here, I don't even know where it is. Somewhere on the plan, it will tell you what the overhang is, like 12 inches or whatever. And Tennessee's really serious about making sure your overhang 12 inches here is the same as 12 inches here, even though you've got 9 and 12 on this side and 14 and 12. In Texas, we would have cut all the tails off and then put 9 and 12 tails beside the rafters and make that work. But then it looks like you're going to Pizza Hut. But what they do here is, see this 7-inch rise difference? The steeper pitch, you raise the plates that amount so that the inside of fascia and inside of fascia, the rafter tails are at the same elevation. And I'd never done that in Texas. That just wasn't what we did. And once I got to Middle Tennessee and Germantown, oh man, they have some very ornate houses, mostly due to Larry showing up and bringing arches and columns back in the 80s and 90s. But yeah, this was fun. I was able to just cut all the different, like, for an example, this long roof here, you would cut like 6 rafters. So they could start one here, put one somewhere back here, and if you didn't have a long enough ridge, you'd put another set. And they could get the skeleton up. There wouldn't be all the rafters. It would just be enough to get the ridge up. And then you could tie in and put the hips. And so you get all the ridge and hips and valleys and skeleton up. And then I can go around and count what you need and cut them all and lean them up against the building. So the guys up here never slowed down. They were always putting stuff up. And then I'd start cutting all these jacks and stuff. And when they were ready, we would figure out how to establish this ridge and tie it together. And these are actual lengths. Here's a floating hip that's 5'6" and 15/16, long to short along the top of double bevel. And it works. I mean, if you really want to get into it and really study it, you can figure this stuff out. And I would work on this like the night before I had to start framing it. And it would take me, I don't know, 3 or 4 hours maybe. But once I'm on the job site, I don't have to do any thinking. I absolutely hate pulling out a calculator, trying to figure something out and fight through all this with all the other distractions and people needing stuff and fat finger something or make a mistake. I never enjoyed that. And once I started running my own show, I got to do it my own way. I would laminate these on 11 by 17 paper and just have the guys start building walls and joisting out and doing stuff and helping where I can. But they knew that I needed to focus on this. And so I would have I think this one took 2 days to cut everything because it just is. It's a lot of custom stuff and getting up there and making sure it's right. Like there's a wall in here, so there's a true valley for a peak inside, but as soon as you got outside to the covered patio, it became a lay-on. And I can't calculate lay-on. I don't even know how to calculate that. You just have to measure it. But yeah, it's Each house is its own custom little animal, and it pays to tackle it the best way for that house. So here's some other things you can do. That's the rafter length. Here's all the jacks. So this is a neat little piece of information, because I'll start with, okay, name it by ridge. This is my way. I don't know if it's the way, but it works. I identify every single ridge, and as you can see, they're blue and they're like a hexagon or whatever number size that is. Pentagon. No, what am I saying? 1, 2, 3, 4, 5, 6, 7. So it's octagon. It's just up on its peak. So octagons, ridge A, ridge B, ridge C, ridge D. So if I was to group these all together, I could turn off ridge G, and all the things that connect to that ridge go away. And that's how I need to know ridge A. Well, I need to know the span for ridge A. I need to know the pitch for ridge A. I need to know the offset here, so that there's going to be a hip, or this is a valley and here's a hip. And that way I have all the right information I need. How many jacks I need, how long's the valley, how long's the hip. Then this circle one was when I did the takeoff. I would, as I'm doing this, I'd say, well, it's going to be, where did I have the ridge here? I don't even know if I measured the ridges. I just knew that I needed a 12-footer here, because you can just count the layouts, or you can pull a dimension with your computer. I don't think I've ever cut a ridge on the ground and sent it up there, unless it's butting into an already existing layout. Because typically I like to leave those ridges a little wild, so that once they're in, they can be cut. But I have to think about that. It's been a while. I'm sure you could do it. Anyways, now I'm just reminiscing. So this is the PDF. I talked about the overhang. I talked about how Construction Master is not accurate with jacks. They're really good about everything else. And this thing takes a beating. It's in one of those armadillo cases. And I use it all the time for things that it's good for. It's really fast to do a lot of things. But I have my own software that I use. Let me just show you the calculator. Here's a emulator version of it. That happens to be a 8 and 12 in degrees. But let's see. There's delete. This doesn't have all my programs in it, because it doesn't store them locally. So it would be a pain for me to do that just to use it. And then when I turn it off and turn it back on, they're all gone. So I haven't done that. But that's the calculator I used. I started on a HP 48SX at Texas A&M in 1990. And man, that thing was expensive back then. But there was no internet, so plenty of time to learn how to use it. So I hope you enjoyed this. The things I want to leave you with are software. Don't just get locked in on one software unless that's all you can afford. Don't let your ego get in the way. I'm a fanboy with Apple because it integrates real well with everything. It's easy. I don't have to do any kind of computer work. Like backdoor stuff, like in Windows, always, you put in a new piece of hardware. Oh, you got to go find the drivers. Oh, blah, blah, blah. I grew out of that. So I understand being a fanboy, but there is no design software that's perfect. Everybody's always looking for the next best thing, because I have to create plans for permit. And Chief does a great job of that. It's just I don't use it for things that it doesn't do well. And I never thought I would use SketchUp. I thought SketchUp was for kids. When I first tried it, I didn't understand the whole sticky geometry and all these bright, goofy colors. And I was like, wow, what is this all about? Where would I ever use this? Well, fast forward and look at this. I colored these just so that they would be segregated. You know, these see-through yellowish main commons. And they've got more than just yellow. I mean, they've got actual like wood and stuff. I'll take you on a quick tour here. Let's bust this open. I tried, wow, see, what is going on? I tried drawing this house in Chief, and Chief brought these rafters into these rafters and then cut the main rafters off and put a ridge board down here. So there was nothing supporting the main roof. Well, this is done in SketchUp, and this would be, SketchUp's a lot slower because, you know, like, well, if you use plugins, let's just say this. There's that Nathaniel Wilkerson's Medique BIM, and this is his foundation tool. It even chamfers the, this is exactly how we did a slab. Well, the only thing we did different in Texas was they would do, I think it's called waffle slab, where they would, every 10 feet, they would dig deeper and run more rebar both directions. So that it looks like a waffle iron when it's upside down. Like you're ever going to see that. But, yeah, look, he's got, you can put steel in sonotubes correctly, and this is welded wire mesh. But SketchUp is a little slow. He's got a wall tool and a roof tool, but I haven't used it enough to get good with it. And so I did this all by hand. Now what's nice is you can be repetitive. Like, I'm going to show you something here. I'm going to go, that's the sound of the Stream Deck doing its clicky thing. I'm going to come up here and I can make it stay in whatever orbit I want. Now I'm going to move this, and now that little plus symbol means I'm going to make a copy, and I'm going to move it 12 inches and hit enter. And then I'm going to go 50x enter. Boom. Look at that. So there's ways to, there's ways to do things once you learn them. So you need to get a book from Matt Donnelly. If you're going to do SketchUp, he's an amazing author. Let's see, who else? Medique, you can buy his plugins. And SketchUp's cheaper than Chief and cheaper than most other design software. So once you buy these advanced SketchUp extensions, you're still coming in better than other stuff. Nick Saunders is an architect out of California who is amazing how he draws. He does a lot of really intricate details in 3D. And so he can just refer to details for every aspect of his project, and totally makes sense when you see him. You totally understand what he's trying to accomplish. It feels like it's the new way to do design when you look at his plans. Dwayne Addy out of Canada, out of Calgary, he's a big SketchUp. There's some top tier people. You can watch a guy named Aaron. He's great. Justin. He's out of Denver. Mike Brightman has tools called Condocs. Can't remember the guy out of Virginia. I bought his book. Was it Brock? John Brock. Bought his book, and he's matter of fact, man. He just tells you like it is, super clear. So you can learn from these guys. They're all successful users of SketchUp, and some of them are builders, some of them are architects and engineers. SketchUp's not for kids. It can be. It totally can be. But I went through here and I thought about everything that I would do as a framer and how I would place it and why I would place it. And then I would go, well, what if I tried something different? What if I did this? Like if you look right here, this is a rake wall right here. And then it ties into a regular wall right here. And so there's a rake stud going up there, and then there's where the next wall starts, tying it together. And then I carried on this double top plate thing at blocking, because over 10 feet you have to have blocking to keep the wall stiff, but also in balloon frames you always want to do fire blocking. And so that just happens to make it better for the sheetrock guys if they come around the corner and they know that all their nailers are at the same elevation as the rest of the house. And I like to do headers to the top, and the only reason that is because we did a hotel in Clarksville, and no, it was assisted living, and on the ground floor they sent out doors that were 2 inches taller than what the plans called for. There was some kind of metal fire rated door, and we had all the headers down like they're supposed to be normally. We had to tear them all out and then put them in, put new trimmers in, or cripples, what do you want to call them. So I learned on that job, put the headers in all the way and block down, because it's so much easier to take off. And I double bottom plate now too, because if I just need 1.5 inches, I just rip that one plate off and I'm done. So not going to catch me again. See this here? That's the old way we used to do it. In fact, this isn't even correct. Because, oh, what is that? Why is that whole wall? Well, let's do this. Let's see if I can get this to move. Move plus. Yeah, I'm a huge proponent of blocking all the way to the end. I don't know why. I'll tell you how it looks to me. You come up this stud, it needs to continue all the way to the top. And look, it didn't even take it. What the hell? All right, so this wall is locked somehow. Let me do M plus. See, it's like grabbing the face. 1, 2, 3. M plus. There we go. Not sure why it's doing that, but we fixed it. And then, so the other weird thing is you have to hit spacebar to unlock the cursor to bring it back to this, and then in Chief you have to hit escape. And I wish I could unify those to where all the shortcut buttons are similar. And that's why I have a Stream Deck. So that's not what I wanted. Let's see. Oh, I want this. So this is the software, how you build the Stream Deck, and this happens to be the SketchUp buttons. And there's a guy on YouTube that shows how to build these. You don't have to have it his way, but his way is so efficient, because I start here at number 1, and this is all Chief Architect, and then there's some more Chief Architect, and then there's some AutoCAD. And the nice thing about AutoCAD, you ever done AutoCAD where you want to draw a line, so you type the letter L, but then you have to hit enter to choose it? Well, check this out. You push this line button, it generates the letter L, and then it presses enter for you. So when you're in AutoCAD and you just push that, boom, it instantly is ready to go do a line. There's some websites. There's some productivity. Don't know what I'm doing with this one. There's SketchUp, and here's just some random utility apps, parallels, so I can have windows. So yeah, man, I tell everybody. Oh, and the best thing is, you can go and get. Let's see, do I have this? Yeah. So you see all these? This is 64 buttons. And you can take an old iPad or a new one, whatever you want to do. Go spend $50, get the lifetime license for the Stream Deck Mobile, and use split screen on your iPad and have 128 Stream Deck buttons on your iPad. And that's a hat tip to Nutty. He does Stream Deck stuff like crazy, lighting and he's sarcastic, so it's fun to watch him. But he's got a great YouTube channel, and he showed this. I couldn't believe I could have every button I would ever need in any single software on an iPad. So the only trick is I signed up for the subscription, and as long as you're subscribing, you can't get the lifetime offer. And so their tech support's great. They said cancel your automatic subscription so that it expires whenever that is. And once it expires, you'll see the new option to buy the lifetime license. So it's either $29 a year subscription, and if you use it for more than 2 years, you had better bought it permanent, or you're just throwing away that $29 that you could go to Starbucks with. So if you like burnt coffee. All right, so I have run this thing almost to a complete hour now. It frustrates me because I had a great video on Zoom with Mr. Larry Belk, and I got to figure out why the technology is like this. What I'm using right now to record this screen is Clean Shot, and it's working great. And it's actually 60 frame, full resolution, so this will be a big video. But there you go. I'm going to keep working on that PDF and check back, or maybe I'll next video that comes out, once it's done, I'll refer to this video so that you can come to the link and get yourself this thing. I'll put some tables in there that'll help when you're planning stairs and other things. I want you all to be the best you can be. So some of you framers are amazing. Like when you watch Awesome Framers, Tim Euler, I used to think I was in maybe the top 10 of being an amazing framer in America. That's how cocky I was at one point. And then I saw Tim. He went to some class where he learned how to do those eyebrows. And I immediately went, okay, well, I'm not in the top 10 anymore because I have no clue what he did. And he's good. He not only does he listen to the good retro 80s music, and he's not afraid to let you know he does, but he clearly verbalizes and explains what he's doing. And so I've always liked watching Tim. You can tell he loves what he does. So go on YouTube, pay a subscription so you can get rid of the ads, and then look up Awesome Framers. He's really good. And that other guy, Kyle from RR Builders out in Illinois, he's another guy that is just legit. He'll just tell you how it is, and with a little bit of humor, and it's great. It's whatever work he has to put into all that to make that work. It's definitely worth it. So I hope he keeps going because it's awesome. He's built quite a library of how-tos for the post-frame industry. And then lastly, Perkins Builder Brothers. They're fun. It's funny how they make fun of Jamie wanting to explain something. And it's fun because he's like a construction scientist. And then they make fun of him. You know, they'll cut the film or they'll speed it up or whatever. But yeah, those are a couple brothers that learned well from their dad, it looks like. And now they've carried on the tradition. So there you go. Let's frame stuff. Man, framing is awesome. Just cutting wood and smelling that smell of Doug fir or whatever you're working with, SPF. And then at the end of the day, you get in your truck and you look back and you go, look what I have. I built this. It's pretty awesome. So yeah, and then let me know if I might post some of these SketchUp models to the SketchUp, whatever that's called, the warehouse, so people can download them and mess with them, see what they got, because I just want y'all to have options. I want to learn what you guys know, and I want people to invent stuff that I hadn't even thought of so that I get to keep growing too. So thanks a lot. Thanks for the video. I have milked this thing out to the last almost exactly 1 hour. Y'all take care. I wish y'all the best. Thanks for watching.